Kepler's third law, the square of time period of revolution is directly proportional to the cube of its semi-major axis. T square is directly proportional to r cube. T square divided by r cube is equal to constant. T1 square divided by r1 cube is equal to T2 square divided by r2 cube. T1 square divided by T2 square is equal to r1 cube divided by r2 cube. Suppose a planet of mass m moves round the sun in a circular orbit of radius r with orbital velocity v. Let m be the mass of sun. Then the centripetal force provided by the gravitational force mv square divided by r is equal to gmm divided by r square. This implies that v square is equal to gm divided by r. But orbital speed v is equal to circumference divided by period of revolution. This implies that v is equal to 2 pi r divided by t. V square is equal to gm divided by r. This implies that 2 pi r divided by t whole to the power 2 is equal to gm divided by r. This implies that 4 pi square r square divided by t square is equal to gm divided by r. This implies that t square into gm is equal to 4 pi square into r cube. This implies that t square is equal to 4 pi square divided by gm into r cube. This implies that t square is directly proportional to r cube. So the square of time period of revolution is proportional to the cube of its semi-major axis.